Hello everyone, welcome to Legacy IAS. We were dealing with time, speed and distance. Now, we had seen these in the initial lectures, that is introduction basic questions related to relative speed. Then we dealt with questions that involved fixed distance or distance being constant. So you equated S1T1 with S1T2, S2T2. Then we saw questions related to average speed, then some train problems. Today we'll be seeing both problems. Now, here there are a few terms that you need to understand. First is upstream and downstream. What is upstream? What is downstream? So upstream is when, let's say this is a boat and this is a river. Now, when the boat is moving in this direction and the river is moving in this direction, when they are going in opposite direction, that you call as upstream. That is, the boat is going against the stream. The other one, that is downstream, in that what will happen? In that the boat is going in this direction and the river is also flowing in the same direction. That is called downstream. Now, by general intuition also you understand that when a boat is going downstream, that means the river is flowing in that direction and the boat is also going in that direction. It will be much easier for the boat to travel. Okay, it will cover distance faster. Now, the general thing is, the terms like, one term is there called speed of boat in still water. Speed of boat in still water, this you can write as SB. Now, speed of boat in still water, that is when boat is traveling in still water, like a swimming pool or somewhere where there is no upstream, no downstream, there is no flow in the water, then that is called speed of boat in still water. So this is SB. Now, speed of boat while going upstream. Now, if the boat is going upstream, whatever is the speed of boat, upstream means the river is opposing the motion. So you will have to subtract the speed of river from it. As we did in relative speeds, if this is opposing the motion of the boat. So this is speed of boat minus this is speed of river or stream or whatever is given. Basically, the medium which is flowing at what speed. Then, similarly, you will have speed while going downstream. So while going downstream, it will be speed of boat plus speed of river. That is, both will be added, speed of boat and speed of river. Why? Because they are going in the same direction or supporting each other. So these are the three terms that are used. Now, one formula that you can observe also, if you add both of them, if you add this speed upstream, this is speed upstream, this is this plus this minus this, and if you add speed downstream divided by 2, now you see I'm adding this and this, so speed of river and speed of river will cancel out, you'll get 2 times speed of boat. Now if I send 2 there, what you get this expression, which is speed of boat is equals to speed while going upstream plus speed while going downstream divided by 2. Okay, so this is speed of boat. To calculate it faster, if upstream and downstream speed is given to you, you can add them both, divide by 2 to get the speed of boat. Now let's try some questions. First question, very easy, basic. A man can row upstream at 14 km per hour and downstream at 26 km per hour. What is the speed of the stream? So upstream is what? Speed upstream is what? The river is opposing the motion. So it will be speed of boat minus speed of river. Now, speed downstream will be what? River will be supporting the motion of the boat. So it will be speed of boat plus speed of river. Now, what is given in the question? A man can row upstream at 14 km per hour. So this is equals to 14, correct? And downstream at 26 km per hour. So this is equals to 26. Now Forget this, you have to solve these two linear equations, and you've already learned how to solve linear equations like these. So this is equals to 14 and this is equals to 26. What you can do, you have to find the speed of the stream. Okay, so what you can do, you can subtract both of these equations. What it will become, it will, this plus will become minus, this plus will become minus, this plus will become minus. What will happen, speed of boat minus speed of boat will cancel out. Minus speed of river minus speed of river, that is minus 2 times speed of river, is equals to 14 minus 26 is what, this is minus of 12. Correct, minus minus again you can cancel out, speed of river will come out to be 6 kilometer per hour. So answer becomes 6 kilometer per hour. Now this is fine, this is what you can do using equations. Now a much more intuitive way to think about it is this. This is speed of boat upstream, this is speed of boat downstream. Speed of boat downstream will be much bigger than the speed of boat upstream. Now what we had seen in that formula, speed while going upstream plus speed while going downstream, if you add them divided by 2 you get speed of boat. So speed of boat will be exactly in the middle. Speed upstream plus speed downstream, speed of boat will be in the middle. Now if you, from this speed of boat, if you subtract speed of river you get speed upstream. So this is minus speed of river. Now here if you add speed of river to speed of boat you get speed while going downstream. Now if you put the values you don't even need to solve any equations. Speed while going upstream is what, 14, while coming downstream is 26. What is the average, 14 plus 26, so it is 30 plus 40, 40 divided by 2, this becomes 20. Now you look in any direction, whatever is the difference, whatever is the difference is actually speed of river. So 20 to 26, what is the difference, 6. 14 to 20, what is the difference, 6. In both cases you are getting 6, which is the speed of river. So using this diagram you can do it much faster and much more intuitively. Understood? Okay, then next, now let's see this question. A boat takes 11 hours for traveling downstream. Okay, 11 hours for traveling downstream from point A to point B and coming back to point C midway between A and B. Okay, so this is an entire journey of the boat in which it is traveling from A to B and then it is coming back to C, where C is the middle point between A and B. Understood? So a boat takes 11 hours for traveling downstream from point A to point B and coming back to point C, which is midway between A and B. Now, if the velocity of the stream is 3 km per hour and the speed of the boat in still water is 12 km per hour, that is, this is what? This is speed of boat, and this 3 km per hour is the speed of stream, that is speed of river. Now, what is the distance between A and B? So distance I have to calculate. Now, I assume this whole distance to be, let's say, 2d. I can assume it to be d and d by 2 also, but let's assume this whole distance is 2d. Now, or let's assume d. So this distance is d. From A to B, the distance is d. Then from B to C, C is right at the middle point. So this becomes what? This becomes d by, correct? So in total, it is traveling d and then d by 2. But this entire journey won't be at the same speed, correct? Why? Because from A to B, now if the river is flowing like this, so river's direction won't change. So from A to B it is going downstream, but from B to C it is coming upstream, so it is changing. Now total time is given to you as 11 hours. So total time is equals to 11 hours. Now this will be equal to what? This will be equal to, time is equals to distance upon speed for both the journeys. So from A to B, what is the distance? Distance is d. What is the speed? Speed is actually, because it is going downstream first, so speed will be speed of boat plus speed of river. This is speed while going downstream. So this is what? 12 plus 3, that is 15. So speed while going downstream is 15. So d divided by 15 plus. The other is going only while going upstream, it is only traveling d by 2 distance. So let's write d by 2. Now what is the speed now? It will be difference between the two, that is 12 minus 3, that is 9. Correct? This is an easy equation. Now you can finally solve for d. So this will come out to be 11. This will be equal to, now this is 15 and this is 18. 18 and 15, what will be the LCM? 18 5s are 90 and 15 6s are also 90. So this comes out to be 90. Now how many times it went? It went 6 times and this one went 5 times. So this becomes 11 is equals to 11d by 90. Correct? 11 and 11 you can cancel out. What you get? D is equals to 90 kilometers. So D becomes your final answer. Understood? Okay. Then next. This is a previous year question. Now what it says? A boat takes half time in rowing a certain distance downstream then upstream. Okay. What is the ratio of speed of the boat in still water to the speed of the current? Speed of the current means what? This means speed of river only. And speed of boat in still water, this is what? Speed of boat. That's it. Now, boat takes half time in rowing a certain distance downstream. So, now, see, distance is same. So, from A to B it is going. Now, while going from A to B downstream, it is taking some time. Okay, so that is T downstream. While coming up, it is taking some time, which is T upstream. Now, if distance is constant between them, that is A to B distance is same. If you are going from A to B or B to A, the distance is same. So time taken, if the distance is same, as we had done in distance constant problem, what we have done, distance is equals to speed into time. So if you see here, it will be speed while going upstream into time taken upstream is equals to speed while going downstream into time taken while going downstream. Okay. Now if both of these are equal, now you see I can write that speed time while going upstream divided by time by going downstream is equals to this. So the ratio of time will be opposite of the ratio of speeds. So ratio of speeds will be opposite that of time. Now what is given in the question? It is given the boat takes half time in rowing a certain distance downstream. So that means time taken downstream ratio time taken upstream. Now this is half. So this is 1:2. So this is 1:2. Time taken downstream is of course less, time taken upstream is of course more. Now can you tell anything about the speed? Yes, the speed will be exactly opposite. Speed while going downstream ratio speed while going upstream will be 2:1. Why? Because distance is constant. So this holds. So 2:1 you got. Now what is the ratio of speed of boat in still water to the speed of the current? Now there are many ways to do this now, but the most easiest way is again drawing this. Now I assume it to be 2 km and 1 km per hour. Does not matter. Only ratio is given to me. Correct. And ratio only is asked. Now ratio only is eventually asked. So what I can do? Simply I write speed while going upstream, speed while going downstream. This is speed of both. Now according to this, this is given to be 2 and this is given to be 1. So speed of boat will be what? This is 2, this is 1. Somewhere in the middle, exactly in the middle, that is 3/2. So if this is 3/2, this is 3/2, then speed of river is what? You see the difference here or here. In both cases, you can see the difference is 0.5 kilometer per hour. So this becomes speed of the river. So now you have the speed of boat and speed of river. Let's write it as 1/2, whatever you like. So you write 1/2 or 0.5. Now what is asked? What is the ratio of speed of boat in still water? That is speed of boat to the speed of current. Speed of current is what? Speed of river. Speed of boat in still water is what? This comes out to be 3/2. So this is 3/2 divided by speed of river is what? 1/2. What will happen? 2 and 2 will cancel out. What you'll get? 3:1. Anyway, you understand that 1.5 is 3 times 0.5. Correct? 0.5 into 3 is 1.5. So ratio came out to be 3:1. Answer becomes this 3:1. Understood? Simple. What you have to do, only remember this diagram and what does speed upstream and downstream mean. Right in the middle will be speed of the boat. That's it. That's it for this class. Thank you.